China has one of the oldest, continuously surviving and thriving civilizations in the world today. The history of China can be traced back to over 4,000 years ago. It was roughly around 2000 BC when the ancient Chinese civilization began to flourish around the Yangtze River. Since then, one dynasty after another rose up and ruled over China. And since the country never went through any major invasion by a foreign enemy or a major disaster, the Chinese civilization continued to grow and prosper in spite of the internal wars and scuffle for power. Fast forward to today, and China has emerged as a global superpower, leading the world in many industries, one of these being construction. One thing that China understands quite well is that if you want to build something big, then you need some big machines. Add a large workforce to this equation, and you have the perfect recipe to build mega structures at unprecedented speeds. In the last 10 years alone, China's laid down a network of over 6,000 kilometers of road every year. China's built multiple bridges for rail and road networks at a lightning-fast pace. Building bridges is neither fast nor easy, but China's proven this wrong with the help of a monstrous machine called SLJ-900. Developed by Beijing Wow Joint Machinery Company, the SLJ-900 is almost 300 feet long, 24 feet wide, and weighs a monstrous 580 tons. A single SLJ-900 can help create almost 750 bridges in its lifetime. The machine only needs the pylons of the bridge to be properly erected in their places. As long as the pylons are properly installed, the SLJ-900 can extend past the pre-made bridge segment to lay down a further segment. Once the segment's been laid down, it can go back and bring forth another segment to be laid down. Even while carrying maximum load, the SLJ-900, or the Iron Monster as it's commonly known, can move at almost 5 kilometers per hour, which makes it light speeds faster than a stationary crane that has to stay rooted on the spot to lay down bridge segments. Before the SLJ-900 was developed, bridge sections were laid down with the help of huge cranes. Anyone who's seen a crane work knows how painstakingly slow it can be to use a crane for construction. It not only requires time, but also a lot of labor, whereas the Iron Monster only requires a minimal amount of labor, thus reducing the overall cost of the project. It can roll on its 64 wheels, both forward and sideways, carrying bridge segments and laying them down. The SLJ-900 is a groundbreaking development in the world of bridge construction. Countries like Russia and India are already eyeing to purchase it from China. It can be particularly helpful in building bridges over rugged landscapes such as mountains and rivers. It's already contributed towards several high-speed rail projects, including a new link between Inner Mongolia and the rest of the country. Now, if you thought the Iron Monster was giant, wait till you see the Kunlun. The Kunlun is a box girder erector. It's named aptly after one of the longest mountain ranges in Asia. The mighty Kunlun has been developed by the China Railway Construction Corporation, and it has the job of laying down the support beams or the box girders of bridges that span over mountains or waterways. According to the China Railway Construction Corporation, Kunlun is one of its kind in the world, and it symbolizes a technological breakthrough in the world of road and railway bridge engineering. It can also perform the task of intelligence coordination during construction and can solve bridge erection and power supply problems in difficult terrains. In June 2020, Kunlun successfully erected the first 1,000-ton box girder of the Fujian-Xiamen high-speed railway bridge. The Fujian Bridge is a cross-sea bridge that's almost 15 kilometers long and is expected to be completed by 2022. For comparison, it took 4 years to build the Golden Gate Bridge, which is roughly 3 kilometers long. The Fujian Bridge is almost 5 times longer than the Golden Gate Bridge and is expected to be completed in half the duration it took for the Golden Gate Bridge. According to a statement issued by the State Council, Kunlun can reduce about 20% of girder erection costs and speed up the process by 25%. What sets Kunlun apart is its ability to operate inside tunnels, although it will need to be disassembled before it can pass through a tunnel. In the past year, Kunlun has laid down beams in tunnels, both at tunnels' entrances and exits. It's passed the tunneling test and given China a competitive advantage in low-cost rail and road bridge construction. Kunlun can be particularly effective in the western region of China, where there are lots of tunnels and deep valleys, leading to bridge and tunnel conversions. Kunlun also uses high-strength steel plates that are aviation and submarine-grade level materials. Kunlun also has a laser matrix system that enables it to drive automatically in tunnels by scanning the surrounding environment. It's a pretty handy machine, to say the least. If Kunlun can lay down beams in tunnels, it can only mean that China has finally cracked the code for making big tunneling machines. Although the word tunneling these days brings Elon Musk's boring tunnels to mind, China's not too far behind when it comes to boring tunnels. Less than a decade ago, European manufacturers ruled the tunneling machine market, and China, like other countries, had to buy tunneling machines from Europe. In 2019, however, China started exporting tunneling machines to Europe for a high-speed railway project between Milan and Verona. Over the last few years, Chinese engineering companies have reverse-engineered tunneling machines and managed to make them in a more efficient and cost-effective manner as compared to their competitors in Japan and Europe. Chinese tunneling machines can dig up to 10 kilometers of tunnels in a day at a cost of $10 million per tunnel. Compare this to the cost of tunneling in the USA, where each kilometer costs around $50 million. The CRCHI tunneling machine has been domestically built and has been used to tunnel one of the twin tubes in the Genshan East Road Highway crossing under the Chentang River in the city of Hangzhou near Shanghai in China. The CRCHI tunnel building machine has a diameter of 15 meters, which includes it among the widest tunneling machines in the world. It has an installed power of about 9,755 kilowatts, a rated torque of 42,784 newton meters, and a maximum excavation speed of 50 millimeters per minute. Like all tunneling machines, it can tunnel and lay down tunneling walls as it plows through. As if this wasn't enough, China is considering mega tunneling machines. The tunneling machines, Kunlun and SLJ 900 combined together, have given China a very decisive competitive edge when it comes to building road and railway networks. These mega machines form an integrated unit and can lay down tracks for high-speed railway projects and roads over difficult terrains. These mega machines have allowed China to speed up the One Belt, One Road initiative, under which roads and railway networks are being laid down all over the region, and not just in China. For instance, China built the Mombasa to Nairobi railway track and completed it 18 months ahead of its time in 2017. The 480-kilometer track was built at the pace of 700 meters per day. This was done with the help of a track-laying machine that transports prefabricated tracks along the railway line, setting down each track and then rolling on a new track over it. Each section of the track can be installed in just 4 minutes. But wait, if you think this is fast, then hold on, because China's developed an even faster track-laying machine. The CYP 500 is a rapid track-laying machine that can lay down 2 kilometers of tracks in a day. In March 2020, the CYP 500 was used to lay down the first section of the China-Laos railway track, which is said to be the longest railway track outside China in Asia, and it's all set to open later this year. If you compare the railway track China built in Kenya with the one connecting it with Laos in a span of roughly 4 years, China's gone from laying down 700 meters of track per day to 2 kilometers of tracks per day. Moving away from industrial-level construction, let's now take a look at how fast China can build in its city centers. Each year, China builds almost half of the world's skyscrapers. But how can China build so many skyscrapers? Well, if you have attentively watched this video so far, then you'll already know the answer. Yes, China has a humongous skyscraper building machine that weighs a stupendous 2,000 tons. This monstrosity can build an entire floor in 4 days and can remain steady and safe for construction even at a height of 500 meters. Its weight allows it to easily bear hurricane-force winds. According to Chinese engineers, the wall-climbing monster can increase building speed by over 20%. It was developed over a period of almost 3 years by designers from the Institute of Engineering Technology in China. Lai Zhai, one of the mechanical engineers heavily involved in the project, has named the machine Bonaut. The Bonaut is over 40 meters high and weighs almost 2,000 tons. The development team for the Bonaut have obtained 8 patents and published 5 papers on the technologies that have been used to construct it. It's no secret that these technologies have allowed China to build at a rapid rate. We still remember how China managed to build a COVID hospital last year in just 6 days. They even live-streamed the construction online. And that's a wrap. If you guys enjoyed this video and want to see more, don't forget to subscribe to the channel and press the bell icon to stay updated whenever we release a new video. Other than that, thanks for watching, and I'll see you in the next one.